All right, we're going to finish the notes and starting with the arc length. The length of any circular arc S is equal to the product of the measure of the radius of the circle and the radian measure of the central angle that it subtends. Therefore, our formula for arc length is going to be S equals R theta, where S represents my arc length, R is going to represent my radius, and then it's important here that theta is my angle and it has to be in radians. Alright, so it's just a basic formula. You're going to look for your given information and then plug in from there. So let's look at an example. It says, given a central angle of 128 degrees, find the length of its intercepted arc in a circle of radius 5 centimeters. Round to the nearest tenth. So I like to start off first by writing out my givens. Right off the bat, I'm given my theta is 128. Well, we need to go ahead and convert that to radians. So remember from the other day, to convert it to radians, I'm simply going to multiply by pi over 180. So I'm going to get 128 pi over 180, which simplifies down to 32 pi over 45. So I have my theta. The next piece of information, it says my radius is 5. So my R is 5 centimeters. What am I looking for? It's saying look for the length of the arc. So I'm looking for S. So based on that given information and what I'm looking for, it's clear that I'm going to use the S equals R theta formula. So I'm looking for S. I can go ahead and replace R with a 5 and replace theta with my radian measure of 32 pi over 45. Because it's saying round to the nearest tenth, that's telling me right away that I can simply enter that in my calculator, just like you see it there. So if I were to type that in my calculator, which I want you to try on your own as well, you should be getting 11.2 centimeters. So I'm going to give you a moment. If you need to try to type that in your calculator, you can do that to make sure you're getting 11.2. All right, the other formula that I want to introduce is your area of a sector. All right, so first of all, I want you to remember, so if I have a circle, a sector is simply a piece of that circle. So this right here would be the area of a sector. So what is the formula we're going to use for area of a sector? It's going to be A equals 1/2 R squared theta, where A is representing my area, R is going to be representing my radius, and theta is still going to be my angle. And just like the arc length formula, your angle needs to be in radians. So let's look at an example. It says find the area of a sector if the central angle measures 5 pi over 6 radians and the radius of the circle is 16 centimeters. Round to the nearest tenth. So right off the bat it says my central angle, so theta, is 5 pi over 6. Now notice this is already in radians, so I don't need to do anything. My angle is 5 pi over 6. The next piece of given information is R. So my R is 16. It's asking me to find the area. So I'm looking for A. So based on this information, I'm going to plug into A equals 1/2 R squared theta. So I'm going to say, okay, 1/2, I can replace R with the 16. Theta is going to be 5 pi over 6. Now again, it's telling me to round to the nearest. Oops, sorry about that, guys. Let me close that. It's saying round to the nearest tenth. So again, that's telling me I can type all of this in my calculator. So I'm going to give you a second to type that in your calculator. When you type it in your calculator, again, if we round to the nearest tenth, we should be getting approximately 335.1 centimeters squared. That's my final answer. Now, guys, I didn't go through a lot of examples for the arc length and area of a sector. Some of the problems I assigned, you may have to solve for your radius, but I think y'all will be fine. Just use your given information, and you're going to be working backwards to solve for whatever it's asking for. Your classwork, the rest of your classwork assignment is on My Father Ryan, so please check My Father Ryan to see what you need to do from the book.